badass coders, soon to be coders, and engineer extraordinaires. In our Python calculator, we are going to add the exponent function and a memory recall function to recall the last result stored in memory. Let's get started. So we can start by creating the exponent operator on the calculator, which is the caret symbol. It's the arrow pointing up, or a circumflex. First, start with our input message to the user. So we can create a comma here, add our caret symbol, which is shift and then the number 6 on the keypad. This is the message that's sent to the user. In the conditions, we want to add this as well, because this is another place where we are looking to verify that the correct symbols or operations are entered by the user. So we can add another caret symbol here. Also, in our invalid operator message, we can include the caret symbol again. This is just information that is relayed back to the user, and then we check the condition to make sure that the operator is an operator we have in our dictionary or our set here. And then down here in the logic, where we check for the operator and then run a calculation based off of the operator, is where we will actually add the logic with our exponent operator. Let's just add an additional elif statement to our if statement here. Add the elif keyword and the operation, and providing that equals the caret symbol, then we will execute an operation here. We can use the return keyword, and then on our passed in input value, we will run the operation here, which we can use a double multiplication sign here. And in this case, you can see that we are multiplying. In Python, the double multiplication operator is the operator that's used for exponentiation. So it raises the number on its left to the power of the number on its right. So what that looks like is, if we replace these with 2 double asterisk to 3, then what we're saying is the base number of 2 is multiplied by itself 3 times. So that looks like this. So it's the same thing as saying 2 times 2 times 2. So the value of 2 multiplied by itself 3 times. There is also a pow function, or a power function. So we could use this pow function where we say the same thing, the number to be multiplied, and then the value of how many times it should be multiplied. So this would return a value of 8. So we would say that 2 times 2 times 2 is equal to 8. 2 times 2 is 4, 4 times 2 is 8. Get rid of this, and we could easily pass in our num1, num2 values here and test that just to make sure it works. Run this. We get the result of 8, so that's working properly. I'm actually gonna go ahead and stick with the double asterisk here. And then we'll run it one more time just to make sure it's working. Perfect. Let's run it one more time just to add some different values to make sure it's working. Our first number is 3 to the second, so 3 times 3 is 9. We successfully added our exponent operation to our Python calculator code. Let's add one more feature today, and we are going to add the memory function to store and recall results in our Python code. We want to be able to recall the history of the resulting operations and their values. We can start in the getInput method here. I'm going to close my console. And on the input operation method, we can add to the message here that we want to tell the user that they can enter MR. And this will and this represents the memory recall operation. And then we also want to check and make sure that the valid operator is entered. So in this case, we are also adding MR. And what we are again saying in this line is, hey, if you entered any of these values here, then we will accept them. If you don't, then we're gonna send you a message saying you have these options to choose from. And so in that message also, we want to reiterate that they can enter the MR for the resulting memory. So far, we've added messages. So far, we have indicated with the MR operation in messages to the user, but logically or inside of our code, nothing is occurring in relation to this memory result or returning this memory result. So what we want to do is actually come into our try block, and we are going to make a check, because if we receive an MR operator, then we want to return that operator, and we want to not return or return no value for the key inputs. So we want our code to stop at this point. So we're going to say if our operation is equal to MR, okay, then we say return the operation and then the values none and none. So we don't want an input prompt from the user for number entries, okay? And so that's what we're doing here in the code, is we're saying that we want to return the operation, but we don't want to ask for inputs from the user here. Now let's jump down to our calculate function, and let's add the memory recall down here. We can create another elif for the operation, and we want to run the conditional check for MR, and then we want to return something here. So what do we want to return? So the user enters MR, and then we actually need to run another check here in our logic. So we want to check a variable that we might call result memory, right? This is where we can store information from the last operation that was run. So we want to say, hey, if this variable that we haven't created yet, by the way, we're going to, but if this variable we've called result memory is, let's say, equal to 0, meaning there's nothing in the memory, then we want to do something here. So we want to return something, and technically what we want to return is, if there's nothing in memory, we want to return a message saying there's nothing in memory. So we could say no result in memory. This might seem a little abstract right now, but just stick with me. And then here, we need to do something to check the length. So we have that length method that we could use. So we could say if len, and then we can pass in our result memory variable. If this result memory variable has a length that's equal to 0, that means there's nothing in there. So then we return a specific message. So we can take this length or this result memory variable here, copy it, and let's move this to a global position in our script, somewhere where it can be accessed by any of our methods. So if I placed this inside of one of my other methods, then I wouldn't have access to it inside my calculate method. So I want any of these to be able to access my resulting memory. So notice that we place this variable outside of any of the other functions, or the methods rather. So let's come back down here in our calculate method, and then we can say else. If there is something in memory, then we want to return the last item. So how do we locate that last item within memory? So we created a set with the brackets up here, and we can access items in that using this syntax right here, where we have the open and closed brackets, and then we can type a number for the item we want to access. So I could say 0. I could say 0 here to access the first item. But what if so once again, let's go over this conditional branch that we have here for our memory recall. We are saying, if we get to this point in our logic, that if MR was entered by the user, which let's just say that it was, then we want to look at a couple more conditions. So we assume they entered it, it comes to this block, and it's found, it was entered by the user. Great. Now we have to run some checks on it. So now we want to say if result in memory, which is our variable up here, it's our global variable for the last operation, that's where we're going to store it. If that is equal to 0, meaning, or a length of 0, which means there's nothing in it, then what are we going to tell the user? We're going to say, hey, there is no result in memory because there's nothing stored in there. But then what if there is something in memory? What do we want to do? Well, we want to say else return one of the items that's in that result memory list. So we can access an index of the item in this fashion with the open and close bracket and then a integer inside. So if I say 0, then that's a 0 index. That's going to look at the first item or the beginning of the list. And the whole point of our memory recall is to access the last item that was entered into that list, like the last operation. So you can find the end of this list by using a negative. So you could say -1, and that actually accesses the last item in the list. And this brings us to the next part, where we actually have to add something to the list. We have to add the last operation to the list. So how do we do that? It might be tempting to want to add to that list within this operation here. It might even be tempting to do that within this calculation, but let's logically walk through what's happening here. It might be tempting to think that we could append the calculation at this point in time within our conditional branches. So we might say that we are going to run this calculation and save it to result, and then run the calculation here, and then return our result. But before we return that result, or while we return that result, we also want to update our result memory. By appending result to that, okay? But then what this means is we have to rewrite all these branches here, and it's going to get really ugly to look at, and we're repeating a bunch of the same lines of code here where we're calling result memory and then appending, calling result memory and then appending. So what we could actually do here is, let's put this back to the way it was, and let's return our calculation here. Get rid of this. And let's remember that after this calculate method is called, it returns the calculation in a result down here inside our calculator method. So this is where calculate is called, and then it stores a result here in this result variable. So why don't we just call our result memory dot append at this point in time, and then attach the result here. So this is a much cleaner option to pass our result into, and then update our resulting memory. So at this point in time, let's check and see what results we get by starting and running the calculator. Enter addition, 3 plus 4 is 7, and then if we run MR, nothing happens because our script is no longer running. So let's see what happens if we rerun our script in here and we use MR. We get a no result in memory, and why is that? Well, we are using VS Code, and when we run our script, our saving process is going to save our operations into memory, but as soon as that script ends, or if we were to close VS Code or even shut down our computer, right? And then we come back and try to run a new operation and enter MR for the memory recall, we are going to get this no result in memory because all the memory's been wiped out. So we want our script to continue while we are still using it. So how do we do that? Well, one thing we can do is we can go to the bottom here of our script where the calculator is started from. And after it's done, we can put a message in here to the user to ask them if they want to continue or end. If they want to continue, it could allow them to enter that MR memory recall to get those results. So why don't we start with a while statement here, a while loop, and we'll say while this is true, we could take an input from the user. So we could call this, well, we could just call the input method here first. And we can say, hey, enter, let's say the letter C, to continue, or exit to exit. Now let's go ahead and run this and see if that works. We can run MR here, no result in memory, and then do we get our message? Enter C to continue or exit to exit. So at this point, it's not going to do anything. It'll take an input from the user, but it won't actually do anything because we haven't added that logic. So it's just going to keep running. So we can come back in here and take our input from the user, but then how do we actually exit out of the script? So we could say if the user input is equal to exit, then in that case, how do we get out of a loop? Well, we can use our break statement like we did above, remember? So we can use break. And then I could take this user input and I could actually declare it up here. So then we get our input from the user, we store it in this user input variable, and then we actually call that user input, and we say that, hey, if what was saved in that user input is equal to exit, then we want to break. So let's go ahead and run this and test this. So I actually had to enter Control C here to end the script through the terminal. And then from here, if we start this, and we could enter anything. We could enter a calculation here, 4 plus 4, or 4 plus 5 is 9. And then if we want to exit, let's see what happens. Oh, and it did work. So we did exit the script here. So perfect, so that works. What do we want to do if we want to continue though? So we could add an elif branch, and we can once again look at our user input. And we want to say, hey, if it equals C, or if it's equal to the letter C, then what do we do? Well, we wanted to continue, right? So how do we continue? Well, how did we start in the first place? What's called automatically? Our calculator. So we can just call it one more time here. And this will help us to continue. And let's run this. And so if we enter, another addition, 5 plus 3 is 8. If we want to continue, we can press C. And look at that. It restarts our entire Python script for our calculator. And then once again, what if we want to exit after this? So we could check memory location, and it does give us the previous operation because the script is still running. And then now we get the message to exit, and then we can exit. So there you go. Our Python calculator is working beautifully. Our memory recall is working, as you can see. And then we want to run a little bit of validation, error validation, on our conditionals in this while loop. So what we could do is we could actually add a little protection over our text inputs, and we could come up here and we could add lower first of all. So that way if someone enters, you know, an uppercase E, X, or I, or T, or any combination thereof, it's going to automatically lower this and look for a lowercase exit. We could do the same down here for the C. That's a little bit of text input validation right there. And we could also add we could add any number of conditional branches, or we could just end this with else and basically say if we get anything else, then either enter C or exit, right? So we could come in here and say print the message invalid input, please enter C to continue, or exit to end. Let's run this and check it. So let's call memory recall to make sure. Yep, and you can see here no result in memory because the script had ended, and we want to continue, so let's use C. Okay, so it's restarted the script. Let's do an add operation here. 3 + 2, 5, and then if, let's say if we want to exit, we can exit. So you can see it's ended, and let's run it again to see if continue works, and maybe even check our input validation. So if I just want to add 2 + 2 is 4, and then let's test our input string validation. So if I run an uppercase C, so it lowercased it and then accepted it. So what if I was to enter a D? Invalid operator. Okay. What if I enter anything other than D? What if I enter anything other than, let's see if this accepts a capital exit, and it does. So it lowercased the uppercase exit and exit the script. Let's run it again, run an operation here, and then let's test that C. If we run uppercase C, it should lowercase it and continue. Perfect. In today's tutorial, we successfully added the exponent operator and functionality, and we successfully created the memory recall functionality within our Python calculator. We still have some more work on this project to build it out, and I will see you in the next video. Hope you enjoyed it.